And we are back. Yeah, been away for a little bit, but we're back. So continuing with human brain inspired artificial neural networks. Uh, let's let's dive right in. So carrying on, neurons transmit information through chemical and electrical signals at synapses, forming the brain's intricate wiring, where neurons that fire together wire together. Yeah, I mean that's funny. That's a little neurologist joke there. But yeah, that is a key concept that compared to static inorganic systems previously, before we started developing neural network models, there's no sort of realigning compared to use creates increased use. So there are feed forward cycles and also feed down cycles. So if you're not getting used, you're not getting aligned. And if you are getting used a lot, then those patterns become more and more fixed. So this is how behaviors are entrained. Like it's a fundamental feature of us, right? So, give Mark nice, positive piece of cake for doing task. Oh, yes, interesting. Do task again. Yeah, neurons firing, dopamine activated. Ears prick up a little bit, and that next reward is there's next easier to align that task, right? So yeah, neurons that fire together wire together. The brain with over 100 trillion synapses. So this is the key thing. The computational power sitting inside one of these 100 trillion synapses is more than giant mega supercomputers. Okay, yeah. The amount of interconnectedness within biological systems is order of magnitude more than older technology, right? So that's the goal. We want highly connected, loads of connections, and the ability to wire and rewire, to have feed forward and feedback systems, yeah, and make it alive and organic. And that is the big breakthrough, and that's why we've got androids, yeah, that behave largely like humans. We shall see. So yeah, brain, 100 trillion synapses, stores and processes information much like a computer. Again, sort of, where the brain matter acts as hardware and the transmitted information as software. So it's more, yeah, it's like hardware plus data stream, because it's like your code is constantly realigning itself. Yeah, so it's like you got a little, as this thing is lining and unlining, and making deeper and deeper connections and wiring together. It's like you're writing the code as it goes, right? Which is pretty cool. The conventional software is programmed to perform specific tasks and only changes when updated by humans. Oh, okay, good. Exactly. Yeah. So traditional software is fixed, whilst biological software is all mutable. Yeah, and some parts are highly mutable, and other parts are way less mutable. Right. So, for example, some of your core functions, like like stuff controlling the automatic systems of the body, like your heart rate, yeah, like that you have no conscious control over, like that there are synapses to do with that, but they basically can't be rewired. Like as soon as they're wired in, they're pretty much there, right? Which is why that, if you have trauma to that, you're dead, right? But then other systems, especially to do with learning and memory, they're like super flexible, right? So the flexibility spectrum can be altered within the body as well. So that's another sort of hyper parameter to play with, right? AI is designed to learn and improve its performance autonomously, yeah, or semi-autonomously, yeah. AI systems rely on techniques like back propagation to refine their models. Yeah, so it's sort of mirroring that. The more you get, you're going to send signals back through the other way. But they still fall short of the brain's unmatched ability to adapt and learn from minimal exposure to new information, since the brain constantly reshapes itself physically as new synapses form or resolve with every piece of information. Process. Interestingly, third generation ANN, named spiking neural network models, right? So, yeah, they've been around for ages, mimic even more human physiology of neurons. and how they asynchronously operate. Yeah, so that was another. So the spiking neural networks also follow that. So they don't. It's not like everything goes at once. You've got like ba-da-da-da-da-da-da-do-do-do. You've got more rhythm, right? More gaps. Okay. So again, more redundancy, more complex signaling. And then you also have like the way that because it's not a binary on off, right? They're gradients of neurotransmitters. So you have distributions of function within even a neuron, right? As opposed to just a binary on off. Yeah, so more complexity in a physical biological system. In order to run better AI, we need better hardware to sustain and feed these advanced algorithms. Yep. So this was his call to arms, which we did. Yeah. Significantly more advanced hardware. Yeah. So the not only in terms of processing power, but we also shrink the chips. We also the huge breakthrough is quantum computing. Which was just when he was writing this. It was just a few little bits and pieces. It was still very theoretical. Like now, they're still expensive and they're still isolated, but it is possible, and they've got incredible applications for probability and statistics. I will probably dive into this at some point because essentially, if you can, I'm not now, but they break the game and potentially break all of in non-chaotic systems. They could lead to near perfect predictions. So you've got a quantum computer that is say doing something to do with online gaming, like gambling. It is the house, it's always going to know the numbers, right? Because it can run every possible solution, right, forward in time. It's anything to do with risk, the stock market. It's just a game changer, right? And it's something that we can't even, we struggle to visualize and understand quantum, things that work at that scale. So yeah, I'm not going to get bogged down in it today, but yes, that has happened, and there are. There's. I'll also come back to her. She is incredible. I'm probably going to do a full video on Dr. Ling Xi as well. I will come back to her. She is an amazing woman and scientist, and went through so much. It's terrible what happened to her, but she's up for a Fields Medal. So new methods in quantum probability calculation and advanced topological networks. So she's just. And then she's done all sorts of stuff, man. She's bit taken with her. But apart from the fact that she's an actual mega genius, very cool author and person. We will come back to her work in the future, but we got better algorithms and we got better technology now. It raises a pivotal question. Should we strive to build silicon-based supercomputers that emulates the brain's complexity? Yeah, so try and get it to be, use silicon-based rather than carbon-based, and try and go that way. Yep, people went down that route, and that's our androids going down that way. Or should we explore integrating advanced computational directly into our neural tissue? Yep, got that too. Well, my friend, she doesn't really talk to me anymore, but. Too cool for me, CJ. She got a neural uplink, so the third generation one, very cool. Anyway, but yeah, people are doing that now. As we push the boundaries of both AI and neurotechnology, we glimpse the possibilities and challenges inherent in each trajectory. Okay, yeah, so there we are. So this is where he does his that's what we need, and this is what we're going to do. So where we stand now and where we're headed, the future of computational innovation. Hardware-wise, traditional computers based on the von Neumann architecture separate computing and memory functions, creating a bottleneck on the limits of efficiency. So he's going to talk about quantum computing and other stuff as well. So As transistor sizes shrink to the atomic scale, which we're well past that, but so at that point, the design faces increasing challenges, including excessive heat generation and energy consumption. Server farms underneath Alaska, up in the Scottish Highlands, Iceland, because well, now that we're, finally, I mean, the huge changes in geopolitics since he was there. We'll go for a little aside here. I didn't believe we did it, but it was amazing that Oceania was formed, right? So, I was always a true believer in this, because the four founder countries, same head of state, same basic legal system, which is common law, so not a constitutional based system, so you can just layer stuff on top. Shared language, culturally, the Aussies, maybe the Canadians are a little different, but still fundamentally, they're very polite, a little bit too polite. Suspicious as a British person, not enough ironic detachment. And of course the Kiwis, who are awesome. Culturally fine. First it was free trade, better military alliance. Then they synced up the financial systems, especially as the US started to go downhill rapidly. Before the sad situation now is 3 years into the Second American Civil War, absolute war zone, becoming like a third world country now, blues versus reds again. Very, very. But anyway, let's not. We'll get into them another time. I'll do politics another time. But So with the attack on New York, still fighting over that. I think they're fighting in Philly at the moment. Back and forth. Basically the New York Stock Exchange shut down, and London, Toronto, Sydney became it's the sun never sets, right? The ocean of finance that the sun never sets, and now the second largest military power in the world, behind the glorious and powerful People's Democratic Technological Republic of China. So we shall see. Everyone's very happy. Of course, Taiwan reunified. They gave the Tibetans back their rights. Outer Mongolia joined freely. All great. UN celebrating. Dalai Lama came back. Freedom of religion. All this amazing stuff, right? After they threw the Maoists out and assassinated Lord Emperor Xi. It was, I remain skeptical. Okay, maybe we'll thrash out some of that stuff at some point another time. But I hope so. I hope, I sincerely hope that the Chinese people get a break. Because it's been, 4,000-5,000 years of having leaders that stomp on them all day. So, it's about time they got a chance to show the world what they can really do without somebody oppressing them all the time. So, anyway, so what I was saying, got distracted, crazy times we live in, crazy times. So now lots of these server farms are in Iceland, because Iceland joined, there's the fifth federal party of Oceania. And talk of Norway joining as well. So very cool. In response, neuromorphic computing. Okay, neuromorphic computing. A new approach inspired by the brain's seamless integration of memory and processing into single neurons, minimizing latency, seeks to overcome these limitations by emulating the dense, interconnected neuron clusters of a neocortex. And that's exactly what we got. So that was that process. We nailed it using silicon-based, artificial networks. Shrunk the system, so then we can have equivalent of supercomputers instead of banks. So now we can upcharge machines. So we can keep a small structured one that you can sit in an office and you can run inside a brain inside an Android or a crab tank if you're Google now. And you don't be evil, guys. Bam, bam, bam. Giant crab monster tanks that can think. Definitely not being evil. No US politics today. Okay, too complicated. Yeah, so we shrunk those. We got those in machines. But then also that also gave us two extra cool things, right? Yeah. One first thing, the first is definitely that in once we had silicon based sort of things that were similar to neurons, it was much easier to achieve brain to mind connections, right? So it assisted the other technology, which is the technology that I prefer, right? So the unification of man and machine, right? Interestingly, Dr. Xi also a fan of this, so that's because she's such a smart and wonderful lady. The next one is that not only you could unify with our brains better because it's closer emulation of that. It also meant that what you could do is with that shrunk stuff, you could achieve a smaller machine, but then you could blow it out to, so if you need to run additional computational tasks in a more conventional way, and, these models are set up because they're all these hierarchical structural models, so you can just fire them off to like a computational, like DreamNet, and, whilst the main core is there, and then if you want to upregulate something, you just fire it off to a server farm in Alaska. So you have these AIs that can so it differed to what we thought. We thought that they would have, like there was this vision in the sort of the 2020, 2030, 2040, where we were going to have tens of thousands of AI researchers, like banks and banks of researchers. And then it was like imagining having a giant lab full of like each one is kind of as intelligent as, your average scientist, computer scientist, and they're all sitting there talking to each other and like organizing each other. And you've got ones organizing the other ones. So it turned out that approach is a crappy approach, right? Because it's fundamentally bottlenecks in the same way that humans do, right? The managers and the decision making bottlenecks it, right? So instead, AIs don't need to do that, right? You can just have it as one guy, right? But he fires it out to do the computational just as models, right? But all the decision making is done by the silicon neural net centrally, yeah. But you don't need 10,000 minds, right? Because the other guys don't need minds. They're just models, right? They're just no, not models. They're layers, yeah, but they're all it's all one big model, right? So then you're not computationally bottlenecked because that super intelligence can manage all that as one thing, right? And then that's one human that can relate to that thing. So yeah, basically you fired all of middle management, right? So AI completely reduced all that, right? Don't try and run your AI labs the same way that your dumb human people do it. Oh, we need a pre-meeting to get the meeting going, and like we're not doing this, and I don't know if Jones is going to be in on Wednesday, right? The AIs don't do that, but they get bottlenecked on the same decision-making things, no matter how smart they are, right? But if you have, a Plato-style philosopher king running the system, he can check up on everything. It doesn't matter, right? No bottlenecks or much reduced, right? So yes, it wasn't the way that people were projecting it, but it's even more effective, okay? Which sped up things even more. To grasp the potential of this technology, consider how far we've come with supercomputers. From the Brain Initiative to the True North chip, from the International Business Machines of IBM Corporation to Intel's SNN chips, we now have Hewlett-Packard's Enterprise Frontier that can perform over 1 quintillion operations per second. But it does require a lot of power, 22.7 megawatts of power, and it occupies 680 square meters. And then, compare this to a human brain, 20 watts of power, yeah, and a compact 1,500 centimeter cubed of space, yeah. A little bit more if you're a Neanderthal, but we talked about another time. Achieving an extraordinary level of efficiency. Yeah, so we have those machines that are the core processing, running, thinking, organizing machines. But then if we do need to blow it out, and we still have all those server farms, no point in getting rid of them, right? And just do raw computation, then we can fire them off to those other stuff, right? So our managers are the synthetic ones, but our workers are the old school, right? And we combine the best of both. Despite these advances, energy demands and physical size of even the most advanced systems remain significant hurdles. Yeah, like it's still there, but but challenges may be addressed by quantum computing. Yeah, and now we are the next stage, right? So there are regular encryption breaks. The gamblers and gaming guys are definitely using this stuff now. Like their income is just going up and up. The stock market is weird. It's acting weird. The RPI just posted some of the largest returns ever. They have I think it's called Dagger, is their most advanced system, and it's killing it. There are still some other ones out there that have more market share and money and stuff, but like quarter on quarter, it's absolutely taken over the world, right? And I guarantee it's because it's a combination of some of these things, right? It's doing something like this, but of course they're not telling anyone what they're doing. They're making far too much money, right? Yeah. Anyway, yeah, I think we've gone long enough. So we'll come back to implementing hardware chips into neural tissue next time. This guy just predicted the future, and that's the coolest thing about this paper, right? Is he was just like, do this, could be this, could be this. He just laid it all out, sitting there studying crazy people, and he saw it all. Yeah, from the minds of the mad came the machines. See you next time.